Alrighty, guys, what's up? Let's do this graphing logarithmic functions, second to last homework assignment of the year. Here we go. So graphing these guys, reminder of what we did in class. The very first thing you have to do in every single one of these problems is setting this inside equal to 0. So you're setting this guy equal to 0 and you're solving this equation. Very easy. Subtract 6 on both sides. You're going to get -6 for that guy. And this is our asymptote. That's what this does. Every time we're solving this inside equal to 0, we are finding this asymptote. That is a vertical line for all of these log questions that you are never ever able to cross. After you've done that, you really just need to get 2 coordinates for these problems. And the easiest 2 coordinates are typically going to be 2 things. Number 1, so this is going to be our asymptote, putting it equal to 0. Putting it equal to 1 is going to be another value that is going to give us a nice and easy number to plug in. So we subtract 6 on both sides and we'll get -5. So we're plugging in -5. Anytime that happens and you plug -5 into here, if you plug -5 in, let's just see what happens. You got log base 4 of -5 plus 1 plus 5, or plus 6, sorry. -5 plus 6 is 1. So I'm just going to work up here. I'm kind of going a little bit crazy with that. Log base 4 of 1 plus 5. The idea here is this is 0. So you're going to do 0 plus 5. Anything to the 1 power is 5. So we're going to go ahead and add 5 to this. So we have -5 and then 5. So -5 and 1, 2, 3, 4, 5. Right there, we have a coordinate. To get another coordinate, you could use your calculator. You can use another method is to make it equal to the base. So we set it equal to 0 here, equal to 1. So we have 0, we have 1, and then here, the last one, x plus 6 equal to 4. This right there is the base. So we're setting it equal to the base. And when I talk about the base, I'm talking about this number right there. So we have x is equal to -2. The point of doing that, when you make it equal to -2, it makes this inside here equal to 1. So when you plug in -2, you end up getting 1 value larger. If that process was a little bit too difficult for you, for any of that, you don't have to do any of this by hand. I want to remind you, you're able to do this on the calculator. So if you go to y equals, clear off whatever's there, you can make this into your calculator. So we can go ahead and hit log base, which is alpha window 5. So we're going down to that number 5 there. You also just hit the number 5 in the calculator. So you need a 4 there, x plus 6, and then plus 5. And then we're hitting second graph to get that table. And you can get errors because it can't be negative over here. So we have to get out of these negatives. Error. Anyways, there's our -5,5 I was talking about. And it has these decimals for these other ones here, but more importantly, this -2 is what I just did, the -2,6. So it's kind of easier if you can figure out those 2 coordinates. But either way, once you've figured out 2 coordinates, you know for sure that it is kind of going up like this, and judging from our notes, the rest of it has to go towards our asymptote. If you wanted to be a little bit extra, I didn't put it as directions in the homework, but if you want to be a little bit extra, you can add that local behavior. The local behavior says as x approaches -6 from the right hand side, it's that asymptote value, we would say f of x approaches infinity, or negative infinity. There you go. So number 2. So number 2, we do have ln. Remember, ln means log base e, but we do exactly the same steps. So we're still going to start off with x minus 1 is equal to 0, which means x equals 1 is our asymptote. There's our x equal 1 at our asymptote here. There's that. Then we want to set x minus 1 equal to 1. We setting equal to 1 is going to give us another good coordinate there. In this case, you get x equals 2. When you plug in 2, that guy gives you 0. But again, if that's too difficult, use your calculator. And this is going to be one where you kind of want to use that calculator for the next coordinate anyways, because if you're setting this equal to the base, well, you're setting x minus 1 equal to e, and, well, what is e plus 1? E plus 1 happens to be approximately 3.78281, but, yeah, it's kind of difficult to graph easily. But it will give you a 1 when you plug it in. So, about right there. And, again, create that graph. And if you're being a little bit extra, you're writing down that local behavior as x goes to 1 from the right hand side, f of x goes to negative infinity. Cool. All right, number 3, same exact idea. Some people get afraid because we have all these extra 4s and numbers and other things. Don't be. You do exactly the same stuff. You set 4x plus 4 equal to 0. A little bit of extra effort this time because you actually have to do 2 steps. Subtract 4, divide by 4, you get negative 1. Here's our asymptote. Is at negative 1. And now we're setting 4x plus 4. We're setting it equal to 1. So we have 4x equal to negative 3, and then x equals negative 3 over 4. A little bit annoying in terms of having to graph it, but that's going to make this guy 0, subtract 1. So negative 3 over 4 comma negative 1's like right there. And then again, just one more coordinate, setting equal to the base, always a good idea. So now we're setting 4x plus 4, we're setting equal to 2. And the reason it's 2 is because that's what the base is. So we have 4x is equal to negative 2, and therefore x is negative a half when you divide both sides by 4. And so you got x is negative a half, and that's going to give this value of 1. So it's kind of like this. Yet again, if you'd rather use your calculator, use your calculator, not a big deal. And it's actually not even a bad idea to check your work on a calculator. Maybe I made a mistake. Let's go check it out. We got log base 2 there. We got 4x plus 4. And just, okay, sorry. 4x plus 4. And then now, after that 4x plus 4, oops. We have to do a minus 1 over here, and we're hitting second graph. And again, we have all those errors, but we have some other things we want to make sure that we got. So we have, so I mean, these are the fraction values, right? So here's some other values that we could have done: 0, 1, so you can kind of get that shape going. We got 1, 2, and I don't know, that shape looks pretty good to me. I'm happy enough with this. If you want to do more local behavior, you can. No need for it if you don't want to. This is going to be a big, huge graph because you have a regular log. Remember when there's a regular log, there's an invisible little 10 there. So you got your, well, you can't really see what I just wrote there, invisible 10. And when you have that invisible 10, makes things a little bit different, but in the end, not too different because 3x plus 15 equals 0. Subtract the 15 over x, therefore equal to negative 5. There is our asymptote at negative 5. And just to prove that you don't need to be doing anything else, you do need to do this by hand, but the rest of it, just calculator it up. So going over here, clear that off. We can go log 3x plus 15 plus 2. Get the graph going, couple of coordinates. You can see a lot of these not the easiest, and what I meant by having big values is to get an actual whole number here. How big of a value would we need to get an actual whole number? Holy moly. I don't think it's ever going to happen. Might not. Actually, it will happen once you get to, I don't know, when 3x plus 15 is a multiple of 10, 100, etc. Not a multiple factor of. Anyways, idea here, graph it nice and neat, best you can. I think values around negative 4 could be good here. So make it negative 3, negative 1. This is pretty good. Negative 1, 3.07. So about right there, maybe. Okay. And how about another value to the left of that? Let's do negative 4, 2.4. So negative 4, 2.4 is like right. Did I do too small of a value on this one? It was negative 1, 3. Oops, I did too small. Should be up there. That one's not even right. And then we just said negative 4, 2.7, like right there. Anyways, you're not gonna be able to create perfect graphs every time. I kind of complained when I saw that 10 there myself. It's really difficult to get this one going because of that 10. But there you go. Easy enough. Let's finish this up. So finishing this up, I gave these questions on purpose. We have these negatives in front. Remember, whenever you have a negative in front of something, that's going to flip it upside down. We put the notes in for these questions for sure. That is definitely going to help us. But the step one is still the same. You got x plus 2 equal to 0, and therefore x equals -2. So you still have this -2. After that, though, again, I do recommend using that calculator when appropriate. So calculator definitely appropriate here. Negative, natural log, and we got x plus 2 and the parentheses -4. Delete this thing over here. And by the way, if you hit graph, you get a graph of what it looks like if you really needed it for yourself just to see it, just like the notes. But if you hit second graph, that table, -1, 4, beautiful little coordinate there. So -1, -4, sorry. There's a beautiful coordinate. And then no more truly beautiful coordinates, but 2, -5.3 is kind of good. So looks like this, and our graph will look like this. Easy enough. Please note, goes to infinity instead of -infinity this time when it looks upside down. Okay. And for this one, calculate the program kind of didn't put the parentheses right. It really should have looked like that. Whenever you have a negative here, this is a weird one because it's going to flip the asymptote. So we have x plus 3 is equal to 0 here, which means x equal -3 is our asymptote. But this time our graph is going to be all on the left instead. But again, we can still use our calculator for all of these coordinates. So we got alpha window 5, 2, -x plus 3 in the parentheses. So there's mine. That's what it looks like right here. And then when I hit second graph on it to get those coordinates, here we go. We have -4 and 0. What a beautiful coordinate. And -5 and 1, another beautiful coordinate. And there's our shape. Please note, this is also one where our end behavior is going to be different, so I'm actually going to write it this time. It's as x approaches -3, and now it's from the right-hand side. F of x goes to -infinity. All right, all done. Have a wonderful rest of your day, guys. Peace out.